Can you hear me? Okay, great. Okay, so thank you for coming to my talk. My name is Insuk, and I am a graduate student at MIT. And today I'll tell you about some of the work that we've been doing on web security, and in particular trying to make threat modeling more fun and less effort for developers. So before I go on, I'm just going to give you a little introduction about myself. I'm a member of the software design group at MIT, which is led by Professor Daniel Jackson in computer science. We do research on a number of different topics ranging from software architecture, requirements, security, safety, all the way down to testing and program verification. And we have applied our techniques to a number of different systems ranging from electronic voting systems, medical devices, biometric systems, and of course web applications. Okay, so the first thing we should talk about is what is threat modeling? Now, in the past, there has been some debate about the exact definition or meaning of the term threat modeling. And still today, depending on who you talk to, you're going to get different kinds of answers. And personally, the way I like to think about it is basically threat modeling is just an act of asking the question, what could possibly go wrong with my system, with the product that I'm going to build? Okay? Now, let's try to make this more precise. Okay? So, as a developer, when you're thinking about security, you're often working with 3 different kinds of artifacts. Now, you might not write all this down explicitly in a document, but you're going to have them in your head at least. So the first thing you need is you need some kind of security requirement. So requirement is basically what your customers want, right? It's something that your customers expect your system to satisfy. For example, if you're building a healthcare app, then your customers are going to expect your system to keep their medical records private. Okay? The second thing you need is you need some kind of description of your system. If you want to reason about the security of your system, then you need to know what the system looks like. And I want to emphasize that the system is not just the code that you write, but it also includes many other things. For example, it includes the hardware component that your software is deployed on. It includes any kind of third-party libraries that you use. So you have to consider all those things to be part of your system. And the last thing you need is you need some kind of description of the environment in which the system is deployed on, right? And distinction between the system and the environment is that the system is something you create, you build yourself, whereas the environment, you don't really have control over the actions of the agents in the environment. And depending on, depending on the kind of environment that you're working in, you're going to have to worry about different kinds of issues. For example, if you are building an app that's going to be deployed on a desktop, that's very different from the same app being deployed on a mobile device. You're going to have to worry about different kinds of security issues there. So, given these 3 things, then we can go back and restate our definition of threat modeling, which is basically asking the question, or trying to answer the question, what are the possible ways in which the system operating under a particular environment could or may fail to satisfy its requirements? Okay? Now, one thing you might be asking is, okay, well, why do you want to bother with building threat models? Why do you want to build threat models in the first place? Right? Why not just build implementation, do a lot of testing, apply a bunch of static analysis tools, and find as many bugs as you can, right? And then release the product once you're satisfied with it. And after all, models are never going to be perfect descriptions of your system, right? They're always going to be details in the final product that you're going to miss in the models. So what's the point of doing this? Well, I think the best and most compelling reason for building threat models is that by doing this early in the development, you can discover issues that become really hard to fix later in the development. A classic example of this is getting your requirements right? So if you misunderstand the customer's requirement, and if you build a product that protects a wrong asset, then it doesn't matter how good, how bug-free the product is, right? You're never going to be able to satisfy your customers. And this is the kind of thing that's just really hard to fix once you have an implementation, right? That's something you can just fix with a simple, bug fix. Now, the second benefit of doing threat modeling is that it allows you to explore different decisions you make while you're designing your system. And it helps you think about the impact of those decisions on the security of your product. So one example of this is if you're building a web app and you're trying to decide how you want to manage your sessions for your users. So one thing you can do is you can use client-based cookies as a way of managing sessions, or you can also implement some kind of server-based sessions, right? And depending on the decisions you make there, right, you're going to run into different kinds of issues that you have to worry about, right? And doing threat modeling really helps you think about these kind of things early in the development and think about the trade-offs between different decisions you're going to make. And lastly, sort of relating back to the first point, is that if you discover these issues early, then you can actually build in mitigations against the attacks into the design instead of relying on patches, which tend to be expensive and not as effective. Yep. On the other hand, I should mention that threat models is not intended for a lot of things. First of all, it's not intended to help you find bugs in your implementation, right? There are other tools that can do this. And second, threat models by themselves don't really give you any kind of guarantees about your product, right? It's up to you as a developer to take the knowledge that you gain from threat models and act on it to make your system more secure. Okay, so how do people do threat models these days? How do people build threat models these days? I believe still the most popular way of building threat models is by drawing diagrams on a whiteboard. Okay? And in fact, I think whiteboard is probably still the most popular way of building any kind of models in software development. It could be architectural model, design model, or data model. It's still really the most popular way. And I think the reason is because, first of all, it's easy. It's not expensive, right? You just need to get a whiteboard. It doesn't require a lot of training. And also, it's great for discussions, right? Once you have a diagram written on the whiteboard, then it's very easy to discuss it with your colleagues. But it does have its shortcomings. And it doesn't provide support for a lot of things that make threat modeling hard. So what makes threat modeling hard? Well, the first thing that makes threat modeling hard is just the sheer diversity of threats that are out there that you have to worry about, right? So if you're building a web app, you're going to have to worry about things like some guy in Russia setting up a server and trying to apply phishing attacks on your users, all the way down to a bad guy trying to eavesdrop on your wireless network. And now, often the times, the attacker is not just going to use a single exploit in order to break into your system, but to make the matter worse, they're going to try to sort of combine different kinds of vulnerabilities, combine into a chain, and it's going to use the chain to basically compromise one of the requirements of your system. So thinking about these kind of things is just really hard. It's a lot of work. And I think the second thing makes threat modeling hard is that when you're building a system, initially, you don't really know much about the system itself, right? You're still trying to make decisions about how your system is going to look like, what it's going to do. And at that point, you just don't know much about the system yourself, right? Even though you're trying to build it. So what this means is that you're not going to be able to predict different kinds of threats that may arise down the road. So what this means is that you can't think of threat modeling as just one-time thing you do, right? So you can't expect to build a complete threat model at the beginning and then, analyze it and be done with it, right? You're going to have to sort of do this over time, incremental fashion. You're going to have to start with a small model and, add more details as you learn more about your system. So which brings up my next point is that if you draw models on the whiteboard, oftentimes once you're done with it, you're going to throw it away. But what you want to do instead is you want to maintain those models. You want to keep them around. You want to be able to evolve them over time. And maybe you want to reuse them later in a different context or for the next iteration of your product, right? So you want some kind of support for being able to maintain these models and evolve these models. And lastly, it's just a lot of work, manually trying to enumerate all the possible threats and trying to think of all the possible scenarios in which the attacker might try to compromise your system, right? It's error prone and it's tedious to do. So at this point, I'm going to introduce a tool named Portal. It's a tool that we designed to address some of the issues that I just discussed on the previous slide. So it's an interactive tool, and it supports incremental modeling, meaning that you can start with a very small model, and you can evolve the model, or you can add details to it, you can analyze it, and you can repeat this process as many times as you want. It supports reuse of models, meaning that if you capture a piece of domain knowledge in a model, you can actually reuse it. You can instantiate it in a different context or later on if you're trying to build different kind of systems where the knowledge might be useful. And it has a built-in library of threats that can be extended. Let's say if you hear about new kinds of threats that are popping up. And lastly, it supports automated analysis. So it will automatically enumerate the threats for you, and then it will also automatically generate attacks for you, potential attack scenarios in your system. And the way the analysis works is exhaustive, meaning that it's going to explore all the possible scenarios in your system. And that enables you to find corner cases that are quite easy to miss if you're trying to do this manually or trying to do this by writing test cases. Okay? So at this point, what I'm going to do is I'm going to give you a very small demo of Poro. So what I'm going to do is I'm going to use Poro to build a model of a very small, tiny online store that provides 4 basic functionalities. It provides services for creating an account, service for logging in, service for placing an order, and then lastly, one for listing the set of orders you have made. Okay? And what I'm going to do is I'm going to show you how Poro can be used to, in an interactive fashion, to basically discover potential attacks on the system. Okay? So at this point, I'm going to switch to the tool. Okay? So this is the web interface for Poro. And on the right-hand side of the screen is the model of the online store written in the input language of Poro. So I'm going to make this bigger so that it's easier to see. Can you see from the back? Okay, great. Okay, so basically, so in a model of a system, you need to define 3 different kinds of things. The first thing you need to do is you need to introduce a set of data types that you're going to use in your system, right? So for example, here I'm going to introduce a data type called user ID, which basically represents the IDs of the users that's going to use the store, right? I'm going to introduce a set of order IDs, which represents different kinds of orders that the user might want to make. Okay? And I'm also going to introduce session IDs, which is what you expect it to be. It's basically the IDs of the sessions that's going to be used to identify users. And then lastly, the password that the user is going to use logging into the website. Okay? Now, here I declare the session ID and the password to be secret. And what this means is that it's simply the fact that the attacker will not be able to guess. I'm making an assumption here that the attacker will not be able to guess the session IDs and the passwords. Whereas on the other hand, with things like user IDs and order IDs, basically you can make an assumption that the attacker will not be able to guess them, right? In fact, in many of the attacks that have occurred, the attacker has sort of exploited, the fact that these things are very easy to guess. Things like user IDs are just not hard to guess at all. So once I have the set of data types I'm going to use, what I'm going to do next is I'm going to define a set of components. So a system is basically a bunch of components that are interacting with each other, right? So the first, in this case, the system has 2 components. It has a component named MyStore, which is basically the server that's going to provide these services. And then it has a component named Customer, which is the user of those services. Now, each component has a number of data fields. So these are basically just database tables that store any information that the server might want to use. In this case, for example, it stores a database table of passwords that map its user ID to some password. It stores the sessions for the users, as well as the set of orders that the user has made. Okay. Now, so next thing I'm going to do is I'm going to basically instantiate MyStore as a type of HTTP server. Okay, so this is a very important step. So what this does is it tells Poro to treat MyStore as a kind of HTTP server. And the effect of this is that any kind of tags that are relevant or applicable to HTTP server are also going to be used to find attacks against MyStore. Okay? Okay, so next thing we need to do is we need to define a set of operations that the component provides, right? This is basically the API for the component. So for example, the MyStore component has an operation called signup. So this signup operation takes 2 parameters. It takes user ID as well as the password. And it's just going to basically insert the tuple from user ID to password into the password database. Okay? And it also has an operation called login. Okay? So what login does is, again, it takes user ID and password, right? And then it returns a session ID. Okay? So this red here is it's a keyword in plural that representing the return value of an operation. And the next thing I should mention is that is this ensures clause. An ensures clause is basically is a condition that the operation will have to satisfy in order for it to be successful. Meaning, basically, it describes, you can think of it as basically access control on the input parameters as well as the output of the operation. So, for example, here, the first part of the constraint, ensures constraint for login operation says that basically the password that's stored in the database better match whatever password the user pass in as a part of the arguments for login. Okay? Meaning, basically, the user has to provide the correct password. Okay? And the return value from this login function is basically the sessions that corresponds to the user. Okay? Okay, and we also got an operation named placeholder, which basically inserts, it takes user ID and order ID and inserts that tuple into the database table for orders. And then finally, we got an operation called list order, which takes user ID and returns the order ID that correspond to the user. Okay, basically the set of orders that the user have made. Okay, so I'm going to move on to the next component. Right? So the component customer is basically, it represents our user, right? It's a user that's going to use my store. So each customer has an ID and a password, right? So you can basically think of it as a user that has, his or her own ID and password. And I'm going to declare customer as being a type of browser. So what this means, again, is that the portal is going to treat customer as being a kind of browser. And any kind of tags that are relevant to a browser are going to be used against customer when it performs security analysis. Okay. And the final piece of the puzzle is the requirement. It's the security requirement that you care about. So in this case, the requirement that we care about here is that you want to make sure that the orders of the customers are kept private, meaning that only the customer and the My Store can modify or access the orders that the customer has made. Okay? Any questions so far? Yes?
What does keyword trust mean?
Right, so it means that basically, so this is going to be part of the used in analyzing requirements, basically meaning that when I say confidential and when I pass some data, it means that data can only be accessed or modified by trusted components. So,
but I doubt if a browser can be treated as a component of the system.
I'm sorry?
I doubt if a browser can be treated as a trusted component.
Right, so that's a good point. Actually, I'm going to show you that. So in this case, I'm going to assume that the customer's browser is trusted, right? So whenever the customer is using the browser, it's not going to try to compromise the requirement. But you will see soon that there's going to be an example where there's different browser that's malicious that's going to try to exploit flaw in the system and try to basically violate the requirement. So that's a good point. Okay, so what I'm going to do now is I'm not going to worry about the requirement yet. I'm just going to tell Portal to generate just some random scenario, right? So I'm not really trying to check the requirement itself. I'm just trying to tell, I'm just asking Portal to, okay, just give me some scenarios in the system. Okay. So when I do that, whoops, something bad happened. Okay. Sorry, I have to run the analysis. Okay, so when I ask Portal to generate a scenario, it's going to basically try to find just a random scenario that is possible in the system, and it's going to display in a graphical representation. So So in this case, so diagram here shows, so the boxes in the diagram are the components. So the my store is the component. And the circles that are attached to the components are basically the operations, the API operations of those components, right? So for example, my store has an operation called place order, right? And that's going to be called by the customer, right? So the edge here between the customer and place order meaning represents the fact that the customer is going to make a call to place order, okay? And the bottom part of the screen shows the initial configuration of the database that are stored on these components. And one thing I should mention here is that a scenario is basically a sequence of steps where in each step basically some operation happens, right? So each step, there's going to be a call that's being made from one component to other component. And you can actually step through different steps of the scenario. For example, in the first step, the customer makes a call to place order, and it's going to pass in two arguments, right? It's going to pass in the user ID as well as the order ID. Now, another thing I should explain here is that, so I have this thing called user ID 0, which just represents some concrete value of type user ID, okay? So the actual content of these data elements are not relevant here for us. But what we care about is just the fact that basically there is some data element called user ID 0, which happens to be a type of user ID, okay? Okay, so what I'm going to do next is I'm going to actually try to check the requirement, the security requirement here. Sorry, it keeps going back to. Okay, so I'm going to, when I click the Analyze button at the bottom, so kind of to see, I'm telling Portal to basically try to find me a scenario, an attack scenario in which the requirement of the system could be violated, okay? So the first thing it finds is it finds a scenario with a single action, single operation, okay? That involves two components, my store and some evil client, okay? Now, you might be wondering, where did the evil client come from? And it came from the fact that my store was declared as a type of HTTP server. And that's going to bring in the knowledge that Portal has about potential agents, bad agents in the environment that's going to interact with any kind of HTTP server, okay? And also, this diagram doesn't show the customer component because the action of the customer is not relevant for this particular attack, okay? So, actually, can anyone make a guess what this attack represents? Any rough guess? Sorry? No. Well, so basically, so it involves evil client making a call to this order, okay? And returning order ID, which is the order ID that we want to protect. So if you look at the initial configuration of the MyStore database, it stores orders that map from the user ID of the customer that we want to protect to the order ID 0. So order ID 0 is the order ID that we want to protect. We don't want the evil client to be able to access that. But what this scenario shows is basically the evil client makes a call to this order. It just passes in the ID of the user, and it's going to get back the order ID, right? So, I mean, this is a very trivial attack, right? It's basically the evil client just, being able to guess the ID of the user that we want to protect, and just getting the order ID right away, right? Now, so this seems like a sort of toy example, but actually this represents one of the classic mistakes that inexperienced web developers make, right? It's basically a lot of web developers make an assumption that the user is not going, the attacker is not going to try to guess the parameters to the input parameters to these operations. But in fact, a few years ago, there was a case where Verizon had this kind of mistake, and someone was able to obtain the text history of any user on Verizon just by applying this kind of attack. Okay? So what we're going to do now is we're going to fix the system. We're going to try to fix the model and to rule out this particular attack. Okay? And the problem here is simply that in the function list order, there isn't any kind of access control, right? Basically, the list order accepts user ID, and it just returns the order of the user. But what we want to do here is we want to change the parameter. We want to change the function such that list order now is going to accept a session ID. Okay? And then it's going to return basically the order that corresponds to the user with that session. Okay? And because the session ID cannot be guessed, because we made an assumption that the session ID cannot be guessed by the attacker, this should actually prevent this particular attack. Okay? So once we do this, I'm going to rerun the analysis. So I'm going to ask Poro to, try to see whether there's still an attack available on the system. Okay? Whether there's still an attack that's possible on the system. So it's running the analysis. And this time it finds different kind of scenario. So it finds a scenario with, again, eBay client interacting with the web my store. And in this case, what happened is basically this attack involves 3 different operations. So let me just step through the scenario. So in the first step, the eBay client is going to sign up. The eBay client is going to create its own account on my store. Okay. And then it's going to log in, and it's going to obtain the session. So whatever session that's mapped to that user ID, right? The user ID of the eBay client. And then finally, it's going to make a call to this order, and it's going to return the order ID. Right? So again, this order ID 0 is the particular order ID that we want to protect. Okay? Now, so what's going on here? Why is the case that the eBay client is able to access the order ID 0? Can anyone make a guess? Rough guess? Okay, so if you look at the initial configuration, initial information that's stored in the database, you see that the sessions database actually maps the different user IDs to the same session, right? So what this means, what this allows is basically when the eBay client performs login and receives the session, it's the same session as the session ID of the other user, the customer that we want to protect. Okay? And this is how the eBay client is able to access the confidential order ID. So again, this is a different kind of mistake, right? In fact, this is a mistake. That's not really about access control, but it's really more about the configurations, right? So it's something that you have to make sure is true of your system. When you design your database, you have to make sure that whenever you create a new session ID, you want to make sure that it's not any of the previous session IDs that's been generated, right? Otherwise, this could allow the attacker to carry out this kind of attack. So what we're going to do is we're going to, again, go back to the model, and we're going to edit the model. So we're going to add a constraint called uniquely assigned and sessions. Right? So what it's going to do is going to basically tell Poro to assume that it's never the case that distinct user IDs are going to map to the same session ID. Okay? So this should prevent the kind of attack that we just seen. Okay? And then we can rerun the analysis again. Okay, sorry. I need to deposit this one back. Yep. And then you rerun the analysis and see whether Poro can find another attack. So what I want to demonstrate with this demo is basically sort of two things, right? The first thing is that even if you have a very small model like this, you're still going to find a lot of interesting scenarios, a lot of different attacks that could actually happen, right? And the automation actually helps you, right? The automation is what enables Portal to find these sort of surprising corner cases that you might miss if you're trying to do this manually, right? And the second thing I want to show you is just this sort of incremental fashion of building and analyzing threat models, right? You start with a model, and then you run your analysis, you find some attack scenario, and you go back and you fix your model. And then you keep sort of doing this again and again as many times as you need, or until Portal finds no more attacks in your system. So I'm going to go back to my slide. Okay, so just briefly, the way the Portal works, so it accepts two different kinds of inputs. It accepts the model of the system, as you have seen, and it accepts the requirement, the security requirement that you want to check. Okay? And it's going to basically combine those two things with the knowledge it has in its library, its threat library. Okay? And it's going to combine those three things. It's going to compile into a format that can be analyzed by the backend engine. And when the engine finds an attack, a scenario is going to basically translate that back into a graphical representation that's displayed to the user. Now, so here are some key ideas that make Portal work, right? The first idea is that just the idea of representing interaction between components as data flow through API operations. So this enables Portal to reason about end-to-end data flow throughout the system. Okay? And the constraints that you write, so those ensures and the configuration constraints you write, are actually the knowledge that you can take to the next phase of your development. These are sort of the specs, your design specs that you need to implement when you're trying to build each one of these components. And the second idea that makes Portal work is the idea that you don't need a complete model to get useful feedback out of the tool, right? You just need to start with a small model. And in fact, less information you give to Portal about the behavior of the operation, more scenarios it's going to explore. This is sort of in contrast with testing, where in testing, if you want to explore a particular behavior, you have to write a test case for it. Whereas in Portal, it's going to always assume the worst case. It's going to try to find the worst case possible scenarios. Okay? And the third idea is the idea of reusing knowledge by instantiating a component as type of another component. So you see an example of this in the demo where I instantiated my store as a type of HTTP server, and that enabled Portal to reason about potential threats on that threats that it knows about server and use that against the my store. And finally, the way the automation works is basically by translating the description of the system as well as the requirement and the threats into a logical constraint. And it's going to be solved by a constraint solver. And any instance that the constraint solver finds is going to represent a potential attack on your system. Okay? Now, I should also mention that there's a lot of ideas that we are borrowing from based on some of the great works that's been done in the past. The first idea that we're using is the idea of attack trace, which was invented by Bruce Schneider. So here the idea is that the tree shows different kinds of actions, different ways in which the attacker could combine different actions. And you can think of a scenario that Portal generates as basically a single path through this attack tree. Of course, there's been a great number of efforts in trying to capture and reuse knowledge that we have about existing threats and vulnerabilities. And the information in Portal's library is based on the data from these databases. Now, in 1970s, Dorothy Denning wrote a paper which has since become one of the most papers in computer security, most important papers in computer security, where she introduced the idea of information flow framework. So basically the idea here is that you want to be able to sort of reason about how information flows throughout the entire program. And you can think of Portal as basically instantiating this framework to the component level, so to reason about sort of architectural level issues. And finally, the idea of using constraint solving it came out of the programming language community, where people have used constraint solving as a way of finding bugs, building static analysis tools, and many other kinds of applications. Now, So there are some things that Portal can't do. In fact, there are a lot of things Portal can't do. First, it can't really check implementation for security bugs, right? This is true in general for any kind of threat modeling tools. Right? There are other tools that can do this much better than Portal. Now, it can't really tell you about attacks that are outside the library, right? So it only knows about the threats that are stored in the threat library, right? Now, again, this is not really an inherent limitation of Portal. You can, if you know about a new kind of threats that doesn't exist in Portal, you can basically add it to the library, and it's going to perform the analysis, and it's going to try to find attacks based on the new information that it has just gained. It can also tell you whether your model is accurate, right? If your model is wrong, then whatever output you get from Portal might not be reliable, right? I mean, basically, it's up to you as the designer of the system to build a model that's as accurate as possible. And what this means is that Portal can't really replace humans, right? You can't really replace human insights and domain knowledge that you have about your system, right? Portal can only Portal is there to sort of help you and automate some of the tedious things that you might be doing right now with threat modeling. So side tips for you. I hope I convinced you that threat modeling is a useful activity and it's worth the investment. And I just want to also tell you about other tools that are out there that you can use for threat modeling. The first tool is the tool called SDL Threat Modeling Tool from Microsoft. So Microsoft has been leading, so there's a team at Microsoft that's been leading effort in trying to get developers at Microsoft and other places to do threat models, to build threat models. And every year they release a new version of this product that you can download for free. Now, Adam Shostak, who's I believe is also at Microsoft, he has created this game called Elevation of Privilege, which is actually a very interesting and fun way of introducing threat modeling to developers. So if you have a hard time convincing your colleagues to build threat models, then this might be a great way of getting them to do so. There's also a tool called Track, which is an Excel-based threat modeling tool that helps you enumerate potential threats on your system. And finally, there's a threat modeler, which unfortunately I haven't tried because it's not free. Okay, so what's next? What's the status with Portal? So I use Portal to model and identify flaws in several web applications. So these are all commercial applications. And in some cases, the result of the analysis in Portal has led to design changes in those systems. And what I'm going to do next, what I'm looking into now is basically I'm looking beyond the web. I'm trying to sort of think about other kinds of domains where this kind of tool could be useful. So Portal itself is generic, meaning they can be populated with any kind of knowledge from different domains. And in particular, I'm looking into applying Portal for medical devices, as well as looking into devices, home automation devices for Internet of Things. And finally, the next feature I'm trying to add to Portal is instead of just generating attack scenarios for you, but Portal can also generate suggestions for fixing those flaws automatically, based on the knowledge it has about common fixes that are out there. So finally, so I'm still doing a little testing, but I believe that tool should be released in October. And so I would love you to try out the tool. And if you have any questions about the tool, if you want to know more about the tool, I will be happy to answer. I'll be around for the rest of the day. And I take any questions. Yes?
When you were doing the modeling, it was a little unclear on how you were able to tell what the specific threat was that you needed to go back to. Because it would say, evil client using this method to get to the store. And so where was it in that interface where it told you what the threat was?
So the threat is basically, it doesn't tell you exactly the kind of threats that is being shown. It's basically, the threat is basically just it's expressed in terms of set of operations that the evil client is going to make, right? So you sort of have to look at the operations. You have to look at the data flow in those operations and trying to basically understand why that evil client is able to access a piece of confidential data. Okay, so that's a feature so it would be nice to be able to sort of categorize a particular scenario into one of the existing sort of patterns of attacks. And that's something that I can add, but I haven't been able to do so yet. Any other questions? Okay. I'll be around if you have any questions. Thank you.